Hi, and welcome to our next junior relations video. We're going to chat about distance time graphs. Now, distance time graphs are graphs that display distance on the y-axis and time on the x-axis and are used to demonstrate the journey of an object. All right, I'm going to get out of PowerPoint and get into GeoGebra and chat about a few examples. Here's our first example. This represents a man or a woman running 100 meters. So, let's start off the time. And you can see they've started the race. Now, on the x-axis, we've got time. On the y-axis, we've got 0 to 100 meters, representing the distance they are running. And there's another scale down here representing the person running the race. So, let's keep the time going. Let's pause this race after 5 seconds. And you can see this person after 5 seconds has run 50 meters. So let's unpause it and let them finish the race. And you can see they've got to 100 meters up here, 100 meters, and it's taken them 10 seconds to run it, which is a very impressive time indeed. So let's rewind this and get another person to run the race, maybe make them a lot faster than humans can run. So let's start off this race. Here we go, we've started this race. You can see the graph is a lot steeper. They're running at a faster pace and the line has a steeper gradient. Now let's pause this person after 4 seconds. You can see after 4 seconds on the x-axis, the y-axis is nearly up to 70 meters. So they're close to 70 meters after 17 seconds. After 4 seconds. They're running at a speed of 17 meters per second. Right, what about if it was me running the race? My speed would be right down here, and let me start my time again. You can see now that it's not so steep. The gradient is not steep at all, and the person running the race after 20 seconds, let's pause it after 20 seconds. After 20 seconds has only run 60 meters, so it hasn't even got to the 100 meters after 20 seconds. Right, what if we decided to give this person a bit of a head start? So we're going to change their starting point. Instead of starting at 0, they're starting at 30 meters. So now as the time starts, you can see that the graph starts at 30, and it doesn't mean that they haven't started at 0, they've started at 30. So if I was to keep going and pause the race after 6, maybe 7, let's pause the race after 9 seconds, they're up to nearly 60 meters, right? But they haven't run 60 meters because they started at 30. Right, let's move on to another example. This example is a distance time graph of dropping a ball from the tallest building in the world. We've got time along the bottom in seconds. We've got height in meters up here. The ball starts up here at about 800 meters. 838 is the height of the building. And let's drop the ball. And you'll see as the ball drops down, we're drawing a distance time graph of what's going on. Notice it's not a straight line graph because the speed of the ball is actually changing. Because of gravity, it's getting faster and faster. So it's actually a curve, and you can see it took about 13 seconds for the ball to get back down to 0, a height of 0, which is the ground. All right, our last example is this example here. This is another race. It's a 200-meter race, and we've got 2 runners running it. Now the first runner is runner 1, which is in red, and he or she is starting at 0. And the second runner is running at a head start of 40 meters. They've been given a 40-meter head start. So they're running from 40 meters. So let's start the time off and let's see how the race goes. Now, because the red line, runner 1 is steeper, got a steeper gradient, they're going to catch up to runner 2. So as I keep going with my time, they're catching up, and you can see they've caught up and they're at the same distance at 10, let me take it back, at 10 seconds. At 10 seconds, both runners are at 100 meters. So as I keep going now, runner 2 has overtaken runner 1, and when I get to the end of the race, or get to 20 seconds, you can see runner 1 has got to 200 meters, but runner 2 is only at 160 meters. All right. Hey, well, thank you very much for watching.